Now, okay, before this probably you could also talk about resolution of forces or vectors. So any kind of a vector, if they have a vector, for example, in this direction, and they have another vector in this direction. Now, if you want to find the sum total of these vectors, the convention is to find the orthogonal components of these vectors, which means that I'm going to take a system of orthogonal axes at right angles, and I want to basically see what are the components of these vectors along these axes, right? And once I've done that, I can just add them up, numerically add them up along those axes. So what does that mean? If, for example, this angle here is theta, okay, this is f1, this is f2, okay. First, this vector I can see is already along the y-axis over here. So I want to break up f1 into its component along this axis and its component along this axis. So a shortcut that first you can explain trigonometrically how this is broken up into its two components, but I let my students know a shortcut. The shortcut is that whenever you have an angle here and you want to find the component of this vector to the base of the angle, that becomes a cos theta term, cos term. So cos of this angle, cos theta. So this component here would become f1 cos theta. And when you're taking the component which is away from the angle, I always tell them that this here will be f1 sine theta. So that's the sine term. So those are the two components of this vector f1. Now you can resolve this vector along the y-axis here, which would simply be f2 minus f1 sine theta, and along this axis here, again that depends on whether f2 is greater or f1 is greater, so you can resolve that. And along this axis here, we only have f1 cos theta. Once you have two vectors which are at 90 degrees, you can simply use Pythagoras theorem to find the resultant. Pythagoras theorem to find the resultant of those two vectors, and you can also find the angle at which the resultant is from the normal, from the horizontal, using trigonometry. So it becomes very easy. So this is how you approach resolving vectors. So once you've done that, now you can go into a proper example and how you want to solve dynamics questions. Three important steps. The first step in any dynamics question would be to draw the free body diagrams. You want to mention what free body diagrams are. A free body diagram is where you're isolating an object from the rest of the system, but you're putting down, or you're going to label it with all the forces acting on the object. And you're going to do this for all the objects which are necessary, right? For, in any kind of an example. We can see this later in probably an example that we'll go through. The second step that they need to do is apply Newton's second law, which is F equals ma. Okay? Here F is the net external force, remember that, on all of these objects that you've drawn free body diagrams on. One feature of a free body diagram. Remember that, for example, if you have an object, you can represent objects with boxes or a dot. It's not necessary to have the real shape of an object. Make sure three important features of the vector arrows that you will draw. One, the length of the arrow represents the magnitude. Okay, so the relative magnitude should be correct. Two, the direction is represented correctly. You must make sure that the direction is represented correctly. And three, which is not as important as the first two, but if there is a question in the exam specifically designed to ask you about free body diagrams, this is also important. The point of origin. The point of origin must be accurate. Okay? So three important features of a free body diagram. And they should always make sure that they are drawing all the forces in a free body diagram. The most common, of course, forces that they'll deal with are weight, sometimes normal reaction. Then they will have tension in strings. What else? They will have, yeah, these are pretty much it. Weight, and oh yeah, in some questions they will also have friction. Okay, these are probably the only 4 forces that they'll ever have to make on the free body diagrams. This will be important, a very important note when we come to uniform circular motion. To mention that these forces are the forces that they draw, and centripetal force is a resultant of these forces and not another force in itself. Okay, so that's about free body diagrams here. Okay, and once they've got the equations of motion, the dynamics equations for all the free body diagrams that they've drawn, the third step would be to find the unknowns by resolving these equations. Okay, so when they have 2 equations here and 2 unknowns, for example, they should be able to find them out. So these are the 3 basic steps in solving any dynamics problems. We've already gone through most of these. Okay, 2.2.12. Let's state the law of conservation of momentum. You want to give an example where you have initial momentum and final momentum, and you can probably elaborate on elastic and inelastic collisions, but it's not very important related to the exams, because most of the exam questions are elastic collisions. So you want to give an example of how initial momentum is equal to the final momentum, and state the law of conservation of momentum in the process. That's pretty much it. That covers the dynamics portion of this chapter.